So this week is all about reviewing some fundamental concepts from algebra that are going to continue to come up in our future math classes. So today we're going to talk about complex fractions, the difference quotient, exponent rules, and polynomial graphs. So we're just going to do a few examples of each to just make sure that we have it down. So for complex fractions, an example of a complex fraction is what I have written here. So it's a fraction that also contains fractions. And here the best way to simplify something like this is to find the least common denominator, or the LCD, of the entire expression. So if I just look at every fraction here, I see an x cubed and I see an x. So I want to find the LCD of x cubed and x. Okay, so what do those both go into? That would be x cubed. So then I would multiply both the numerator by x cubed and the denominator by x cubed. Right? And I'm only multiplying really by 1 here, but it's going to significantly simplify this. So if I distribute, I should get 4x cubed minus, now 1 over x cubed times x cubed will just be 1 over 3x cubed minus, now one of the x's will cancel, so I have 2x squared here. And now we have something that is not a complex fraction, it's just a regular rational expression. So if we want to simplify, now we've gotten rid of the fractions within the fraction. We can go a little bit further here. I would usually do is like factor everything, but just for the purposes of this example, we just want to make it, not a complex fraction anymore. All right, so let's look at one more example here. So here we have 3 fractions within this one fraction. We have this x over x minus 1, x over x plus 1, and the x squared plus 1 over x squared minus 1. So now we want to find the LCD, and the denominators I see are x minus 1, x plus 1, and x squared minus 1. Well, what's x squared minus 1? This is really x minus 1 times x plus 1. Oops, not b. So if I think about the least common multiple or denominator here, it would just be this product, right? Because x minus 1 goes into this and x plus 1 goes into this. So the LCD would just be x minus 1, x plus 1. Okay, so I'm going to multiply everything by x minus 1, x plus 1 on both the top and bottom. Okay, so when I distribute the top, I'm going to write this all out so we don't get confused. So I'm going to distribute this whole thing to this term and to this term, right? So when I multiply it to the first term, I'm going to have x times x minus 1 times x plus 1 over x minus 1. So these will cancel, minus x times x minus 1 times x plus 1 over x plus 1. So these will cancel. And when I multiply the denominator, x squared minus 1 is actually x minus 1, x plus 1. So when I multiply these, I'm actually just going to cancel both of these, and I'll be left with just x squared plus 1. So if I rewrite the numerator, I should have x times x plus 1 minus x times x minus 1 all over x squared plus 1. And if I distribute things on the top, I'll have x squared plus x minus x squared plus x, distributing this negative sign, all over x squared plus 1. And these x squareds will cancel, and I can combine the x's, so we get 2x over x squared plus 1. Right, so we no longer have any fractions in the numerator or denominator, so we're all good. We've simplified it.